All right, well, thanks so much, Jerry. Appreciate that. Good to be with everybody today. My name is Matt Burns, Technical Marketing Manager at Samtec. Really excited to be here at Embedded Tech Trends in person. I don't know how everybody feels about that, but I'm really excited to be back to in-person events. It's always good to see our colleagues in person versus on Zoom so much. Samtec, as most of you, if not all of you know, we're one of the leaders in the high-performance interconnect solution space. And today we're going to talk about a theme that has been introduced in many of the presentations today, high-performance I/O, specifically for next-gen embedded applications. I had someone ask me recently, what does it mean to be embedded? What does an embedded application mean for you? And I kind of gave us, I don't know if it was the best answer, but it's what it came to me off the top of my head. Embedded is basically non-data center. I think about my daily life. Almost everything that we interface with has electronics in it, right? Has some sort of MCU in it or some sort of intelligence. Many of us flew here from different parts of the world. I mean, I know Patrick Mayshon and some other folks flew in from Europe. So we appreciate everyone that flew a long distance to be in here with us, or to be here with us at ETT. But at least some airplanes have in-flight entertainment. That's definitely an application of embedded technologies. It's something that's been around for a long time, and depending upon the airline you fly, you may continue to see more of it. I originally gave a version, I originally used a version of this slide. I gave it a presentation in Las Vegas last year. Obviously, when you go to Vegas or any other gambling capital, you look at the technology that's in gaming, and it continues to have more higher definition graphics. The storytelling that's a part of it continues to increase, and a lot of that's just based on higher performance computing. My son is an 18-year-old senior in high school, and like many of us, he can't function without caffeine. So at his request, his mother and I bought him a nice coffee machine recently so that he could do well in school, hopefully. But the functionality that's on a coffee machine these days, Keurig, whatever the case may be, continues to increase. Many of us got here. I took a taxi from the airport to get here to the hotel. Many of us use EVs. Whether there's technology in the car, technology in the EVSE, we just see embedded intelligence everywhere we look. But that's today. We look at these everyday examples, we see various levels of intelligence in systems today, but what's it going to look like tomorrow? And that's really the focus of our presentation this morning from Samtec's perspective, is what's enabling the embedded technology of tomorrow. And when you start to look at next generation embedded applications, it's all about higher speed, higher functionality, higher performance, higher precision. From Samtec's perspective, we tend to look at these as trends that affect various markets, various segments. It's very hard to find an industry application or a customer application that's not being affected by artificial intelligence. And I'm not talking about cloud-based artificial intelligence that's in the data center. I'm talking about the fact that there are a growing number of AI chipsets or AI functionality that's on embedded solutions that are redefining the products and the solutions that affect our daily life. AI and machine learning are going to revolutionize various aspects, almost all aspects of our life. We also expect to see the number of solutions on the market grow at a rate probably 4x traditional semiconductor growth. There's been a lot of data to show how that market's going to grow probably at 10 to 15% a year versus mid-digits for semiconductor growth for the rest of this decade. Embedded vision, especially medical imaging. Obviously, we use embedded vision for a lot of our product inspection throughout our global facilities. Robotics, especially being used in medical applications. And automotive 2.0, whether that's autonomous vehicles, charging, the electrification, whatever the case may be. When you look at all of these applications, these embedded applications for next generation solutions, it all comes down to speed. How can I get data from point A to point B as quickly and as efficiently as possible? Bob Holt, I want to give him a shout out because a lot of the things that he covered in his presentation when it comes to PAM4 and signal integrity. We're not going to go into a deep dive here. We're not even going to mention that in this presentation from Samtec. But without all those capabilities, not only for the interconnect companies, but also for the semiconductor companies, these next generation applications would not be possible. So what are some of the things that we're seeing that are driving these next generation applications? One of the things that's been mentioned is the fact that speed in the most popular protocols is getting faster and faster. I've been told and I've observed by numerous specialists in our industry that if you look at any embedded design, it's more than likely that they have, that it includes Ethernet, PCIe, USB, or DDR. And whether that's avionics, mil-aero, medical, whatever the case may be. If you look at the slide here on the right, this is a graphic that's been put out by the PCI SIG group repeatedly. And it's real interesting when looking at this that the data rate of PCI Express technology, going back to its, originally to the PCI, has doubled every 3 years. PCI Express 6.0 was released in 22. The throughput per channel is 64 gigatransfers per second. And PCI SIG also mentioned in earlier last year that the next generation of PCI SIG technology, or PCI Express technology, PCI 7, would target 128 gigatransfers per second. Now, some of us in the room are probably thinking, I'm just trying to implement PCI 3. I'm just trying to implement PCI 4. When am I going to ever get to PCI 6 and PCI 7? Well, a few years ago, we were saying, well, I'm at PCI 1, I'm at PCI 2, when I get to PCI 3, when am I going to get to PCI 4? So I think that the graphic on the right helps to illustrate that when it comes to embedded applications, even though whether we're in defense electronics or just embedded, we're only a generation or two behind what the data center companies are working on. So the need for speed, again, not to quote Tom Cruise, but the need for speed is always there. I'm glad someone laughed at that joke. You got to at least get one person. Anyway, some of the marketing trends, we've really seen this throughout the pandemic, ubiquitous digitization. Jerry kind of mentioned it earlier, 3 years ago, how many of us were on conference calls 20, 30 hours a week using Zoom or Teams or whatever the case may be? Granted, the pandemic forced us to adopt that technology faster than anticipated, but everywhere we look, every aspect of our life is being digitized. We look at the data communications connectivity through wireless networks, 5G, 6G, and that's redefining productization use cases for us across the embedded ecosystem. Autonomous vehicles, which we talked about, factory floor, HPC workloads. Industry 4.0 is just driving huge amounts of data across manufacturing, and we see greater number of open standards. I talked a little bit already about the evolution of PCI Express, but we also see 100 gigabit Ethernet in embedded applications. We see USB 4, which gives us data rates of up to 40 gigabits per second on the channel, as well as manageability and intelligence sensors. So some of you are thinking, hey, this is great. This is a lot of marketing trends. All of us are seeing similar things in our particular industries, our particular companies, our particular applications. What does a connector company like Samtec have to offer, or how do you contribute to these trends? And there's a lot of detail on this slide, but the biggest thing that I hope you take away from it is that in any case, when you're trying to get data from point A to point B as quickly as possible, as efficiently as possible, with an optimized signal path, that's where Samtec's focus is at. We recently crossed the $1 billion sales threshold in 22, which we're really excited about. And one of the biggest reasons for that sales growth for Samtec is the fact that we continue to focus on developing bleeding-edge silicon-to-silicon connectivity solutions. And when we talk about the markets that the companies here serve, as well as the additional markets that we touch, sometimes data center, datacom, medical, mil-aero, automotive transportation, when you start to look at this, there's a lot of design trends that customers from all swaths are focused in on trying to solve. Signal integrity. How do I get my signal from point A to point B as clean and as efficiently as possible? How do I get as much power into as small of a solution as possible? For a lot of the folks in this room, how do I have swap optimized industry solutions, whether that's Vita, MOSA, SOSA, PICMIC, whatever the case may be. Extreme performance. Not only is that data rate at copper, but as Bob Holt talked about, how can I get that, whether that's in the copper domain, the optical domain, or even in the RF domain? High frequency going out to 110 gigahertz and beyond. And when you look at all of the solutions that Samtec offers the market, silicon to silicon connectivity solutions, we have something for each of those challenges that our customers and the industry is facing. And we're really focusing on whether it's our flyover technology, which Bob, by the way, if you want to come work for Samtec, we're happy to come up with some sort of arrangement, because you championed the flyover technology better than probably we could. But whether it's flyover or copper or power or whatever the case may be, we have the solutions that our customers need for their embedded applications right now and also into the future. But with that being said, what are some of the things that we're working on that we've seen an impact in the industry so far? One of the things that we continue to see that is a major driving force when it comes to embedded applications is the use of computer on modules or system on modules. COMs or SOMs, the basic concept, if it's new to you, is you have a single daughter board with a CPU module with compute core functions, memory, power, I/O, and then instead of the OEM focusing in on developing application-specific COMs or SOMs, all the functionality can be put down on the carrier board or the base board. Some of the benefits of using COMs and SOMs when it comes to production is the fact that you can go from prototype to production on the same platform. It allows for faster time to market, reduced development costs, scalable product range, and the rest of the benefits that you can read on this slide. What's of interest, though, is that when looking at high speed, high performance, the design challenges that data center OEMs have been working on generation after generation after generation are slowly morphing into the embedded development ecosystem. So how can the industry, how can Samtec, as well as some of the other partners we have in the embedded ecosystem, tackle those challenges together to minimize design time, but also come up with a solution that fits the market? And that's really that's really some of the effort that has been put into the computer on module for high performance computing, or the PICMIG COM-HPC standard. PICMIG COM-HPC started as a concept probably about 5 to 6 years ago. A number of like-minded companies got together and saw that COM Express, even though it continues to be the workhorse of embedded computing, had a finite lifespan in terms of its performance. Maybe not necessarily in terms of it being available on the market, but the connectors, as they were at the time, could only get up to PCI 3. And with a number of the embedded chipsets coming from Intel, AMD, and some of the emerging embedded computing platforms, FPGAs, SoCs, GPUs, there was really a need to come up with a new standard that would harness the power, the performance of those combined solutions, but allow for an open-based standard that the market could adopt. That's really where COM-HPC came from. You can see when looking at the differences between COM-HPC and COM-E, the number of enhancements, the number of channels, the total throughput, the power that's available to enable high-performance, next-generation embedded applications. Just a few key points. COM-E 3.0, when COM-HPC started, was limited to PCI 3. Obviously, the new COM-E 3.1 allows for expansion up to PCI 4, but COM-HPC right now supports PCI 5 with a path forward to PCI 6. Obviously, we're real excited about that. Not only has the speed of the channel rates increased within COM-HPC versus COM-E, but the total number of lanes of PCI Express supported has more than doubled from 32 up to 65. We've also taken the platform from being able to support 40 gigabit Ethernet, 4x10, all the way up to 100 gigabit Ethernet, 4x25 to support 100 gigabit throughput. And you can see from the comparison of the table there in the center that there's additional power for TDR. We can support additional memory from full-size DIMMs or SODIMM modules. And then from connector standpoint, we have increased I/O going from 440 pins all the way up to 800 pins from the SOM down to the carrier card. You can also see from the graphic on the right-hand side that the number of modules that are supported by COM-HPC provides for flexibility, scalability, and system growth in terms of performance from module A all the way up to a module E size. I really like the graphic because you can see that the electromechanical hooks from size A all the way up to size E, it's very scalable to go from one to the next, assuming you design your carrier card as such. What's also nice is when scaling from A to B to C, which is what you'd use for client applications, it's very easy to scale in terms of the number of DIMMs and number of SODIMMs that are supported, and the same thing for D and E, scaling from 2 to 4 or from 4 to 8 when it comes to the memory that's used in those types of systems as well. Now, some people ask, is COM-HPC designed as a replacement for COM-E? And the answer is no. COM-E is going to continue to have a key place in embedded computing standards. But COM-HPC allows for so much more performance. Another good example of why COM-HPC provides such a path forward for next generation embedded applications is the power that's supported. When you look at the TDP for some of the server for some of the server chips that you have on these solutions, you can support up to 150 watts on the TDP of server-grade embedded computing applications. And when you look at the power draw of the entire system, you can support up to 350 watts of power delivery from the carrier card to the COM or the SOM itself. Something else that's new for 23, and Jess, if I say anything wrong, you can tackle me later. But the COM-HPC committee, a technical working group, continues to innovate to respond to market needs, market requests. The new COM-HPC mini form factor, which is labeled on the top part of the slide on the right-hand slide, instead of having 2 connectors for 800 pins, this is a smaller form factor which mimics a lot of the similar sizes with COM-E. This is targeted using the same connector as the COM-HPC dual connectors that will just have 1 connector on it. But the thought process is the smaller size, the more compact credit card size location opens up the performance advantages of COM-HPC to a number of embedded applications that may not have been supported using a module A size. From Samtec's perspective, obviously, we're real excited to see the adoption of COM-HPC because the more COM-HPC that's used, the more our connectors will be supported. So our COM-HPC interconnect solutions, just briefly, have been designed to support the PCI 5 and 100 gigabit Ethernet performance. We're not going to go through the SI data, not only from a simulation standpoint, but we also have, or from the test data, we have all that available. Everything that we've provided to the market space today proves the performance of PCI 5 and 100 gigabit Ethernet. These connectors are very small. The footprint is very small, roughly 70 millimeter by 9 by the stack height. And what we're really excited about, again, is the power delivery. So the pinout of COM-HPC was chosen as such to make sure that we get the full 350 watt deliverable to support the highest performance embedded chipsets. We talked earlier about the continued growth of PCI Express. So Samtec continues to innovate in terms of the PCI Express interconnect solutions that we offer. Obviously, we have the card edge sockets that support PCI Gen 1 all the way up to PCI Gen 5. We also have our PCI Express edge card cable assemblies, which can act as jumpers or extension cables throughout the system. Something we continue to see also in next generation embedded applications is extending PCI Express over longer distances. PCI Express over copper, you can probably get to a couple meters using our extension cables. But by using our Firefly onboard optical engines, we're basically able to take a PCIe electrical signal turn into a PCI Express optical signal, and then we can extend PCI Express over up to 100 meters. So there are a number of applications, number of customers that we've been working on that are interested in remote access using PCI technology, whether that's transparent or non-transparent bridging. We also have some hotspot capabilities with our adapter cards that we've developed with our partner, Dolphin. And it can be targeted at hosts or target operations as well. One last thing I wanted to mention, talking about high-speed I/O. PCI Express obviously is a ubiquitous technology. Something else that's also ubiquitous is Ethernet. I tend to think of Ethernet the first time I use it. RJ45s on the back of my PC or on the back of my docking station, but RJ45s are not really targeted for industrial applications or next-generation embedded applications. So the new IEC 63171-6 solution has really been targeted to ruggedize and simplify single pair Ethernet for Industry 4.0 applications. So some of the key features of Samtec single pair Ethernet, we can support multiple Ethernet specifications. We have good current carrying capability for power over data link up to 4 amps. We also have flexibility in our single pair Ethernet solutions to support both twisted pair and twin-ax cable solutions for higher data rates. So what are some of the key takeaways? When we look at the embedded applications that we're going to define tomorrow's solutions, we really see the need for continuously supporting higher speeds, high performance. Samtec silicon-to-silicon solutions are really designed to enable high-performance I/O connectivity in those applications. We just mentioned 3 briefly, our PIC-MIG-COM HPC, our PCI Express, and our single-pair Ethernet. We've completely rebranded a number of our key literature initiatives that define our high-performance I/O solutions. Those are listed on the slide here. Those are available for download for any of the media partners here. You can download directly off our website, and you can also visit samtec.com for more information. We do appreciate your time, and we look forward to interacting with everyone throughout the remainder of the show. Sorry, Jerry.